All right, so for example 1, we're going to estimate the value of the following limit by making a table of values, and then we're going to check our work with the graph. Okay, now if you look at your given function, it says we're finding the limit as x goes to 2. Okay, you're finding the limit as x goes to 2. So we're going to make a table of values as x approaches 2. Okay, and then just make sure that you have 3 from the left and then 3 from the right. So when you're picking your values, what you want to do is have some that are at different decimal places. So like you can see I have the 1.99, that's to the hundredths, to the thousandths, to the 10,000ths. You want to make sure that you do have different decimal places in there and not all the same, because if they're all the same, then they could be the same exact y value. So you want to have some variation there. Now I'm going to show you a different way where you can find values for your table. So I'm going to have x squared plus x minus 6 divided by x minus 2. And you do have to put parentheses in the top and the bottom for this. And before, just to show you, like if I had the 1.99, I could also make this and go by 0.001 on my table. So you can put your change in your table to whatever you want it to be. And then look what happens when you get to 2. You have an error, right? Let's look at the graph of this. The graph of this looks like what? Yeah, it looks linear, right? So what probably happened with this? Yeah, there's a hole, which means if you factored the top, what would be one of the factors? Yeah, one of the factors is going to be x minus 2. Do you guys know what the other factor is? X plus 3, because you can see the y-intercept right there as well. So there would be a hole there. Do you guys know how you can plug in values here and find them? Yes or no, but you're dying to know? So if you go to second and then the trace button, that's the calc. You're going to have values, so you could press enter, and then your x, you could put 1.99, click enter. So 4.99 is going to be your y value. Okay, so I can do that again. So calc, value. Now if I want to see what happens at 1.999, enter, 4.999. You guys want me to do one more? Good talk. What do you guys think? Which way do you guys like to do that? Do you like the table or do you like the graph? Or do you like plugging it in and doing it algebra? Table? Graph? No algebraic? Yeah, once you get to the 1.99999, right? We don't want to square it and then add and then subtract. Yeah. Okay. Now what we're going to do is we're going to sketch this graph. So we have the rest of our values. Now you can tell just from your table that it looks like you're approaching what? Yeah, it looks like you're approaching 5. Okay, so with your graph, like I said, we're just doing a sketch of that. So if you look exactly at 2, we talked about how that's going to be a hole in your graph. That's why you're getting an error there. So even though it looks like a straight line, there is going to be a very small gap, and that's going to happen at x equals 2. We know that that's true because if we plug back in 2, you're going to have 0 on the bottom. That's when you would get 0 over 0, which we've already talked about today, is indeterminate. Okay, so you're going to draw a sketch of your graph as well. And then once you're done drawing your sketch, see if you can write out your solution, just like how we did with our other example up above. Okay, so see if you could write that out. Okay, so let's see how we did. So the way that we could write our solution is the limit as x approaches 2 of x squared plus x minus 6 over x minus 2 is equal to 5. What's that? Yeah, so if you look at your table, you're going to see that it's 5. So your limit, really this part is what your question is, and then alright, you guys ready for the next one? Okay, so the next one is similar, except if you look at your equation, we have the limit as x approaches 0, and then the tangent of 3x over x. Okay, so we can still start by putting that in our graph. Is there anything you guys think we should remember about this? Or what's special about this one? What kind of function is it? It's a trig function. Yep, okay, so it's a trigonometric function. So, is there something we should remember? Or, yeah, what mode should we be in? So whenever you're graphing a trig function, you need to be in radians. Okay, so we're gonna change our mode. So if we go to mode, we're gonna go to radians. Okay, and then we can find our values in a similar fashion to what we did before. Now this is as x approaches 0. Okay, so we want numbers that are gonna get closer and closer to 0. And for this graph, I just switched it up and I put my ones that were from the right first and then from the left. You can do that either way. I just thought it was easier for you guys to visualize first what would be closer to 0 in terms of our decimals. So like the more zeros that are in between the decimal and the value, the closer it's going to be to 0. Okay? So the 0.0001 would be closer to 0 than just 0.01. Okay, so you don't have to pick a certain point. You just have to make them so that they're in different decimal places. So like if it's 0 or really any number, number, I put whatever whole number would be below it. So for 0, it is going to be the actual 0. And then it'll be I'll do 3 zeros sometimes, 2 zeros, or 1 0. You just want them to be in different places. So like the hundreds place, the thousandths, the 10,000ths. You just don't want them all at the same place. So you don't want them all to be 1,000ths values, because then they're so close that they're going to be the same in a lot of cases. Okay, and then again, you can choose how you're finding this. So if you want to use your graph, you can absolutely use your graph. If you want to use your table, you can use your table. We have our good old tangent graph here. Okay, so if I wanted to figure out what happened at 0.01, I'd have those right there. Okay, and it says that we are going to round our y values to 5 decimal places. I did write a little note that my calculator had to be in radian mode. And then for sake of time today, I am just giving you your values, okay? Okay, so we're going to round them out to 5 places, and then once you do that, it's pretty easy to tell from the table what value that you're approaching in this case. If you also go to your table set, if you start at like 0.01, but then let's go up by 0.0001. Okay, as you get closer and closer to 0, you're going to see that you're getting closer and closer to 3. But see how all of these are the same? That's why if you're too close, you're going to get the exact same thing for all of them. You can also, let's bring it out a little bit more. Let's just do 0.1. Okay, so look, even if I just went by 0.1, do you guys see how different this looks than if I'm really, really close to it? So just going up by, the 0.5, 0.4, 0.3, you can see how far apart those are, which is why you do want to have some that are clustered towards your value. Okay, so then the limit as x approaches 0 for the tangent of 3x over x, that would be equal to 3. Okay, so we talked about this a little bit already today, but the limit does not exist. So some functions are not going to approach a finite value at every point. When this occurs, we say the limit does not exist, and yes, it's a real thing, just not from Mean Girls. But we talked about some values that are not finite, like infinity or negative infinity. So if it's approaching infinity or negative infinity, then the limit does not exist. So example 3 says we're going to use a graphing device to determine whether the limit exists. If the limit exists, estimate its value to 2 decimal places. Okay, so for A, we're given the following function. And the first thing that we're going to do is graph, and then we're just going to draw a rough sketch of that graph. Okay, so I'm going to go to y equals. Okay, and then I have this graph here that's going down, and then from the left it's going down as well. So I know that there's going to be an asymptote at x equals 2. How do I know that algebraically from the function? What's one way that what's the only way that we find vertical asymptote? Set the denominator equal to 0. So if you set the denominator equal to 0 and solve, you're going to get x equals 2. Now, when you set up your graph, first let's look and see what happens from the left. Sorry, maybe that was too fast. Okay, so from the left, I chose 1.9, 1.99, 1.999, because those were all close to 2. I got negative 90, negative 9,900, and then negative a million. Now 1.9, 1.99, 1.99, they're all pretty close together. I have all my different decimal places. Are the numbers that the y has close together? No. But it looks like they keep getting more and more negative, right? Okay, so yeah, they're getting bigger in the negative direction. So what's happening is you're looking at this part of the graph right here, okay, where it's getting closer and closer to 2 from the left side, and it's going to approach, really, what value is this approaching? Yeah, negative infinity. Well, you can see this from the graph, but we can verify it with the table that from this side, look, we're also getting closer and closer to negative infinity as we approach 2. And this is from the right side. So we talked about how infinity is not a finite value. So for this, if the limit is going towards negative infinity, we say that the limit does not exist. Okay, and that's because infinity or negative infinity is not a finite value. Okay, what questions do you guys have for me at this point? You guys want to try B? Okay, good. So for B, you can start with graphing it. And again, I just want to remind you to include your parentheses because it's going to be exponential. Okay, and then we're just going to draw a rough sketch of the graph. So for B, the limit is going to be as x is approaching what value? For part B. Yeah, it'll be 1, so it'll always be right there. Yep, so x is approaching 1, and then let's look at our graph, okay? I just drew a rough sketch of what that would look like. Okay, and I know that there's going to be some kind of asymptote in between those. There actually looks like there's going to be what kind of asymptote that I didn't write on there? Yeah, slightly. You guys remember how to find it? Yeah. Divide, and it'll be the quotient without the remainder. Okay? Alright, so then if I'm getting closer and closer to 1, do you guys feel like you could pick some values for your table? Yeah. Yep. 0.9, 0.99, 0.999, those would be great choices. Okay, and then coming from the right side, will be some good choices from the right side. Yes. Yep, good. So 1.0001, 1.001, 1.01, all those are great. Okay, your graph or your table isn't going to necessarily look the exact same as somebody else's, and that's okay. Right? That's perfectly fine. If you do start to look at your table, okay, if I wanted to start at, because it's approaching 1, if I wanted to start at 1, go by 0.01, it kind of looks like from the table I have here, it's getting really close to what value? Here, we can even, here, I'll do 0.001. So as I'm getting closer and closer to, well, that's farther away. I'm getting closer and closer to 1, it looks like my values are getting closer and closer to what? Yeah, it kind of looks like -8, right? Like negative 0.802, negative 7.98. Okay, so because they are getting really, really close to -8, that's what we are going to say it approaches. So that one wasn't as obvious as some of the other ones, but you can see here that you are getting really close. If you're unsure because they are so close, something that you could do is put in another value. So like 0001, so something that's even closer to 1 to see what happens. Okay, and then you can start to see, oh look, the negative 7.99, the negative 8.002. Okay, so your answer for that one is going to be -8. For your homework, you should be making your table of your 6 values. For 5 through 10, the table's given for you to fill out, and then you can use your graphing calculator for some of those as well.